Okay, so I'm just going to go over solving differential equations that are of this form up here. So where you have, you know, y double prime with some coefficient plus y prime with some coefficient plus y with some coefficient, possibly that coefficient is 0. So I just want to work through these three equations here, 1, 2, and 3. And we'll start with number 1, but first there's two things that are really important to just point out, which is if you have y equals, some number a times natural base e to the power of cx, so c is just some constant and x is your variable, the derivative of this with respect to x is going to be y prime is a times c times e to the power of cx, and the second derivative of this is going to be a times that constant squared times e to the power of cx. And this c is possibly a complex number. It might be like 4i or something. And then the second, so this is kind of the first really important thing for solving these types of problems. And then the second is the relation e to the power of I times x is cosine of x plus I sine of x. And similarly, e to the power of minus ix. So these are just things you have to memorize. Or you can prove them from Taylor series, but it's easier just to memorize it. Okay, and now you can say you can add these two equations together and say e to the ix plus e to the minus ix. That's going to be, well, it's going to be cosine of x plus cosine of x, so it's going to be 2 cosine of x. And then it's going to be plus I sine of x minus I sine of x, which is going to be 0. So plus 0. And similarly, e to the ix minus e to the minus ix is going to be cosine of x minus cosine x, which is going to be 0. And then plus I sine x minus I sine x, so that cancels and you get plus 2I sine x. Okay. And so this is the second kind of relationship you need in order to solve this kind of from a fundamental level. Okay, and that's it. So when I'm going to start solving these problems, so these things that are circled in blue and red, you probably just have written down on a note sheet somewhere, and you should just save that. So let's solve problem 1. And the way that you solve differential equations is you just guess at what the solution is, and you basically plug it in and see if it works. So for equation 1, we have 4y double prime plus y prime equals 0. What you do is you guess based off of your experience, which you'll get by solving dozens and dozens of these problems, is say, okay, y is probably going to be something like some number times e to the power of cx. And this would mean then, then we'd have y prime is going to be the derivative of this, which is going to be, let's see, we're going to bring down a c, so ac e to the cx, and y double prime is going to be a c squared e to the cx. Okay, so now let's plug this in. Now plug into equation 1. Okay, and I'm just going to switch colors here and say we have 4, and y double prime is going to be this, so it's going to be ac squared e to the cx, and then plus y prime, so plus y prime is going to be ACE to the CX, and that's going to equal 0. Okay, and now I'm going to just draw out my logic, cancel A, and we're allowed to cancel out A since A is not equal to 0. If it did, you would just have y equals 0, which technically is a solution. So we will have 4c squared e to the cx plus ce to the cx equals 0. And now we can cancel out e to the cx. Again, we can do this since e to the cx is never going to equal to 0. And again, I'm stating this because if e to the cx were 0, then you can't, quote unquote, cancel it out, because that's really dividing by 0, and you can't do that. Okay, but in any case, now you have 4c squared plus c equals 0. And now we're just going to rearrange. So we get 4c squared equals minus c. And now we're going to divide both sides, which is the same thing as cancel out, divide both sides by c. And again, we can do this since c is not equal to 0. Because if it were, then we would just have, write this in a different color, just a hypothetical. If it were, we would have y equals ae to the 0, which equals a. And again, this technically is allowed if you want to consider constant solutions, because then you'd have, up here, you'd have y, if you have y equals to a, which is just some number, say like, 7 equals a, then y prime equals 0, and y double prime equals 0, then your equation 1 becomes 0 plus 0 equals 0, which is true, but not helpful, so you don't want to consider these solutions. So we're going to continue on past this and say, okay, now we're going to cancel c on both sides, so we're going to be left with 4c equals minus 1, and then divide both sides by 4, and we get c equals minus a quarter. And that should give us all what we need for our answer. So if we plug this in, now we're going to plug into y and check. We're going to get, I'm going to change colors just for checking purposes, so it's easier to see. We're going to get y equals ae to the minus quarter x, and the derivative of this is going to be minus 1/4 ae to the minus 1/4 x. And the second derivative is going to be minus a fourth times minus a fourth times ae to the minus 1/4 x. And minus 1/4 times minus 1/4 is going to be 1/16. And the rest is unchanged. Okay, and I'm going to just move my screen down. So now we're going to plug all this into our original differential equation, which was 1. So we're going to have 4 times the second derivative of y double prime, the second derivative of y, which is y double prime, which is 16ae to the minus 1/4 x, and plus the first derivative of y, which is just minus 1/4 ae to the minus 1/4 x. And this should all equal 0. And I'm just going to roll down one more time. And so this is going to be 4 divided by 16 ae to the minus 1/4 x minus 1/4 AE to the minus 1/4 x equals 0, and we can see that indeed 4/16 is a quarter, so this cancels, and you get this is equal to 0. So we're good, and you have your solution. And technically, you should also have a constant here, plus some undetermined constant. Call it b. Again, just a number, because the first and second derivative b is going to go away. So this is your answer for 1.